Topic 4-4, Factoring Trinomials, Day 2. This is more about factoring. It can be referenced in your whole textbook in Chapter 8, Section 3 on page 540, and Section 4, page 548. Alright, we're going to do some more with the box method. This might be new to you guys, but I do think that it is one way of doing factoring. I also teach a crisscross method, so if this just starts to be too confusing to you, then come see me and we'll do a different way. There are different ways of tackling trinomial quadratics to factor it, but I'm getting used to this one myself, and it's a pretty good box technique is helpful. You're always going to put the first term in this box, the last term in this box. So you might go through and make your boxes like I did, and let's just put them in there. 5q squared and the 5, 2r squared, and a negative 14. Make sure you take the minus sign with it. 10y squared here, there. So notice that the products across the diagonals for each of these boxes is, I've put the products here. This one would be negative 30s squared, negative 25s squared, multiplying those diagonally, negative 28r squared, and 10y squared, oops, I forgot my squared, would times 7 is 70y squared. Alright, the sums, this number for each one of these comes from that right there, negative 13s, that when I add these two diagonals together, when I add them, I'm going to have this number, but their product multiplied together is going to give me a negative 30. Same thing here. The sums would be a negative 3q, the sum is a 3r, the sum is a negative 19y. So then it takes a little bit of mental math. You're just looking at each one of these and deciding which numbers you're going to put in each of the boxes. So let's look at the first one. You know that it has to add, or combine, I'll say, to a negative 13, but it has to also be a product of 30. So again, you can look at your products of 30 in your list on your factor pair page, or throw it into the calculator in y equal button that we've already reviewed, and you will find that you're going to be using, for this one, a negative 15s and a 2s. And in this case, it really wouldn't matter which placement you put that, because this is only an s. If it has no number other than 1 in front of your trinomial, then it wouldn't matter which way you put these in. But in this case, then you would look at what this is going to be multiplied. That would be 15, and then this one would have to be a 2. This is positive. So you've created your binomials along the sides of your square, so you would write it in its factored form as s minus 15 and s plus 2. Alright, let's look at the next one. If you're to fill in this one, it has to have product of 25 that gives you an add-in of 3. You know, on this one, that doesn't work. There is not a product, there's not a whole number that would go here. So you can either write not factorable, or also another term to call this is that this is prime. It's already in its smallest form. Like when we do prime factorization, you're putting it into its smallest form. So this equation is not factorable. Okay, let's look at the next one. You needed a sum of a 3 that's going to give you a product of 28. So again, you might put in 28 in your calculator and just glance at the factors to see which ones adding together would give you a positive 3. Alright, so a positive 3 and a factor of 28. Well, that would be a 7 and a 4. Now notice that I put the 4 here instead of here because I'm going to actually, it doesn't, if you put your 2R here, then your 4R would have been there. But I'm going to put the 2R up here so that I know that's has to be a 4 when I multiply by a -2. And this, of course, would be just a +7. Again, remember, it's this times this to give you that. This and this multiplied together give you this one. This multiplied by this gives you this. And the outside will give you this one. Just like a grid. Okay, one more on this side. Again, we're looking for products of 70 that give us a sum of 19. Okay, this one's a little trickier. You might go ahead and put this in the calculator. I'm going to go ahead and show that one to you. If I put in y equals, and we're going to put in 70 divided by x. Go to the table. And what we need is something that's going to add up to 19. Well, 7 and 10 don't work, so keep going. What about 14 and 5? Wouldn't that give me the the 19 that I need? Yes. So let's put those down. So let's put 14y here and a 5y here. The only way that those two would give me a -19 is that both of them are negative. So both of those would have to be negative. So after you've done that, now fill in the outside of your table. Notice that this is a 5, so I can't put my 5y here. The 5y would have to go here. So if you fill in the table first, that may be helpful. And then this would be a 2y to get to a +10. What is it that you multiply by here? Would be a -7. Multiply by here, -1. Therefore, creating your binomial. 5y minus 7, 2y minus 1. Go back to this one and make sure you put that one in too. 2r plus 7 and r minus 2. The more you do this box method, you might like it even better. I keep making it, can't seem to make it not flash too fast. I'll try to work on that. Okay, so let's try some of these. Again, I've put out to the side what the sums and products would have to be. So filling in where everything needs to go first might be helpful. So let's do that. You've got your 4y squared in this one and your -3x squared in that one. U squared goes here, b squared goes there. 5k squared, -2n squared. And again, you want the products going this direction in the diagonals that have been left blank to also be the -12x, what I show out here, -12x squared y squared, u squared v squared, and -10k squared n squared. All of that's gone this way, but you also know that their products are going to be that way. You're just looking at the sums too. So let's see, what can get me to a sum of 4 with a product of 12? Well, I do know that a 6 and a 2 will, but a 2 would have to be negative and a 6 would have to be positive in order to get a +4. And make sure you put your x and your y. These both have double variables on those. Let's just go ahead and fill in all our boxes and then we'll go to the outside. What's going to give us a 2 as a sum? We add together, but a product of just a u squared v squared. Well, that's just going to be a uv and a uv. If you want to, put a 1 out here. Because if I add those two together, I'm going to get 2, but if I multiply 1 times a 1, I'm just going to have a 1. Sounds a little bit trickier. Okay, and then the last one, you've got, you need it to be the sum of 3. Let's see, 5 kn and 2 kn. But if I want it to be a +3, got to decide which one of these is going to be positive, 5 or the 2. The 5's got to be positive. No, I'm sorry, I forgot. This one, look over at your problem. This is actually a negative. So the 5 has to be negative. If we need to see that, just look here. 5 kn and a 2 kn yields a -3 kn. So this is what you're looking for over here. But again, if I multiply those two together, I'm going to get this product. If I multiply these two together, I get this product. If I multiply these two together, I get this product. So now we're ready to, I went ahead and did all three of these, but you do need to go back and break it down into its expanded form and making sure you put the numbers in the right place. Look at the first one again. I can put a 2y and a 2y, and the reason I chose 2 instead of a 4 is there's nothing I can multiply by out here if one of these was a 4 to get 6, but I can multiply something by 2 to get 6, and that would be a positive 3. And since there's double variables, we're going to have variables everywhere. Here, the only thing I need to multiply by 2y to get negative 2xy is just a negative x, because we need to make sure it was negative. You've got your binomials. Walk over here and put them into its factored form, where you have 2y plus 3x and 2y minus x. So you might take these down to their factored form and then check with your teacher. I'm going to go ahead and stop this one here. And that concludes 4-4.